So here we are, we're looking at notes for lesson 4-12 for algebra, average rate of change versus constant rate of change. Keeping in mind that linear equations are unique because they have that constant rate of change, meaning that it's the same. Okay, so example 2, given the following graph, find the average rate of change given each situation, or better than situation, giving each interval. I live on a busy road. People get a little crazy sometimes, and sometimes all the time. Okay, so A is asking us from A to B, which is clearly talking about the point A to the point B. And so, again, to find that average rate of change, we use that change in Y over change in X. I'm just gonna, oh geez, okay. Yeah, crazy stuff is happening to me. Okay, there we go. I'm just going to real quick label each one of these XY because you guys know I constantly mess those up. So from A to B would be using the A to B points. So 3 minus 9 over 3 minus 6. I don't know why I'm using black. Everything else, let's use different color. All right, so 3 minus 9 is negative 6, and 3 minus 6 is negative 3, which is equal to a positive 2, because 6 divided by 3 is 2. Okay, so part B wants us to find the average rate of change from x equals 6 to x equals 9. Okay, well, that's not a huge deal. That's talking x equals 6. That would be point B that has an x value of 6. And an x value of 9 would be point C. So this is really talking about from B to C. Okay, so 9 minus 11.2, because my y's are on top. And then 6 minus 9 on the bottom. 9 minus 11.2 is going to be 9, 10, 11.2 is going to be negative 2.2. And 6 minus 9 is going to be negative 3. That does turn out to be something. Let's open up our handy dandy calculator and see what that gives for us. In the meantime, I want to start talking about this situation C over here. This is some weird looking notation, but don't freak out. We're going to see this more and we're going to talk about this more. This is what is called interval notation. And all that means is that, not obviously, sorry, I didn't mean to say that. This piece is clearly talking about x values because of the x in the middle. So this 3 and this 9 are both x values. And it just means from 3 to 9. That's all that means. Okay, our calculator's loaded. So let's try our 2.2 divided by 3. Divided by 3. Barney, can you please come back here and stay up here with me? My dog was neutered on Monday, and I need to watch him to make sure he doesn't eat his stitches. Okay, so that is a disastrous looking 11 over 15 for this guy. Sorry if that was confusing. Okay, so C is asking us to find the average rate of change from x equals 3 to x equals 9, which is talking about from A, x equals 3, to x equals 9, which is C. So this is really from A to C. Okay, so A to C. So we've got 3 minus 11.2 on the top and 3 minus 9 on the bottom. 3 minus 11.2 gives me negative 8.2 on the top. And 3 minus 9 is negative 6 on the bottom. Divide negative 6. Again, ugly number. 41 over 30. Yeesh. Oh, I didn't mean to put that there. It's a little early, I guess, this morning. Boop, boop. 41 over 30. Okay. And so I just want to pause for a second and talk about the fact that, notice, these three situations do not have the same average rate of change, which means that they cannot be represented by a linear equation, which makes complete sense because if we look at our graph, that graph is not a line. That is not a straight line. It has a different rate of change. It has a different steepness depending on where in that graph you're looking at, right? From A to B, that's way more steep than it is from B to C. So it makes sense that from A to B, that's going to have a larger slope than from slope or rate of change than from B to C. Answering part D to finish this off, which has the greatest rate of change? Well, 11 over 15, that's less than 1. 41 over 30 is bigger than 1, but not as big as 2. So which has the greatest rate of change? From A to B has the greatest rate of change. Boom. And there's example 2.